Hello everyone. Today we're looking at the problem count mentions per user, which was question 2 in weekly contest 434. So this is not really that hard of a question, but the description is very long. There's a lot of things to consider. So just really take our time to go through all the different parts of it and make sure we understand. So we're given an integer number of users, which represents how many users we're going to have in this problem. Then we also have an array of events, and each event is of size 3. So each event can have two types. So the first is our message event. This event is going to include the word message to tell us the type. It's going to include the timestamp, which tells us what time this event occurs, and also a mentions string. So this event indicates that a set of users were mentioned in a message at this timestamp. And the mention string can contain a couple of different things. So it can either contain a string, which contains multiple user IDs. So we'll get a string, which will be separated by a white space with multiple IDs. It can contain the word all, and this means that all of the users were mentioned in this message, or here, which means only the online users were mentioned. So again, for a message event, we can either get a list of IDs that were mentioned, we can get all, which means that all the users were mentioned, or we can get here, which means that only the online users were mentioned. There's also the offline event, which is our second event type. So this has offline to specify it's an offline event. It also has a timestamp and an ID. And this event indicates that a user will become offline at this time for 60 time units. Let's call it seconds for our case. So when we get this event, it's going to tell us that at this time, this user is going to go offline from now until the next 60 seconds. So the goal of this problem is we want to return an array mentions, where mentions I represents the number of mentions the user with ID I has across all message events. So really, what we want to do is we just want to return an array that has all the mentions for each user, how many times they were mentioned. And a very important point here that we want to think about, and you'll see why later, is that all users are initially online, and if a user goes offline or comes back online, their status change is processed before handling any message event that occurs at the same time. This means that if we have any type of online or offline activity, those have to be handled before we handle any messages which happen at the same timestamp. Looking at an example, we have number of users equals 2 and a series of events. So we would output 2 here. And we do this because initially all users are online. Then at timestamp 1, ID 1 and ID 0 are mentioned, so we'll increase mentions for both users. At timestamp 11, ID 0 goes offline, and then at 71, ID 0 comes back online, and here is mentioned, which gives both users one more mention. So we're going to look at a slightly different example here, but this really demonstrates some of the complexities with this problem. So you'll see here already that this is the order we get our messages in. We have a message at time 2 for all online users. We have an offline event at 2 for user 1, offline event at 1 for user 0, and then a message at time 61 for all online users. But you'll see here, the timestamp 2 is coming before 1, and then we have 61 at the end here. So already we could see that our messages are out of order. So let's first sort these and make sure that they are in the proper order to work with. So now I've reordered the events, and you'll see that we're going both in order by timestamp, so we have 1, 2, 261, but I've also changed in this 2 timestamp the order that these messages occur. And remember that the description said that any offline or online events have to be handled before any messages at the same timestamp. So here we see we have timestamp 2 and 2 here, but this offline event has to happen before this message. So that's why when we're sorting, we also make sure that we're going by timestamp, but if there are any messages of the same time, we have to make sure that these offline ones get handled first. So then from here, let's think about how we're actually going to keep track of our users and their state. So because our constraint is rather low, we can only have up to 100 users, we can kind of just brute force this in a way that we can look at every user for all of our messages. And what will that look like? So we're going to keep three things. We're going to have an online set or hash, and basically what that will do is it will keep track of each user by their integer and whether or not they're online or offline. So we start with all our users as true, meaning that they are online. Similarly, we have a mentions dictionary, so it's going to have all our user IDs, 0, 1, and 2, and then also have 0 mentions to start. We're also going to have a queue here, and what this is going to do for us is it's going to keep track of the time that our users are going to come back online. So let's process and see what happens. So the first event here, we're going to process this offline event. So what does this mean? So this means that user 1, or rather user 0, is going to go offline starting from now until 60 seconds from now. So how do we handle this? Well, we can put this in our queue. So let's say that in our queue, we're going to put 61 and we're going to put 0. And why do we put 61? Well, we know that we're going offline at time 1 for 60 seconds. So the time we're going to come online is going to be at 61, and at this time, user 0 will come back online. And we'll see how we use this in a little bit. Also, now that this user is offline, I also have to update my value in my online dictionary. So this value is going to become false because this user is now currently offline. Now for the next event, we'll do the same thing. We see at timestamp 2, user 1 is going to go offline. So I can put that in here. I'll do 62 since I'm going on offline from time 2 plus 60. And then at that time, user 1 will come back online. But also here, I have to update my value in my online dictionary to indicate that this user is now offline. So we see 0 is false and 1 is false. Now we come to our message here. And this message tells us that here, at this time 2, we're going to mention all of the online users. So what we can do here is we could say, all right, well, let's go through my online dictionary. And I can do this because we're only storing up to 100 users. So we could do this without too much cost or too much time. So we can do is say, all right, let's check. We'll see 0 is offline, so nothing to do here. 1 is offline, so nothing to do here. But then we'll see that user 2 is still online at this time. So what we can do is we can update this value here to a 1. So now we process that event and we can come down to this message here. So here are where things get interesting. So you'll see here that we are at timestamp 61. So what do we do here? Well, what we need to do is that we also need to check in our queue and see if as we're processing these messages, if any users are coming back online. And we see here that at time 61, user 0 is going to come back online. So what we do here is we would remove this from our queue and say, okay, well now this user 0 is going to be back online. So what I do here is I'm just going to update this value back to true to indicate that user 0 is back online. Then I actually have to process the message. So what I'm going to do is for all online users, I'm going to mention them. So I'll come to 0. I will say, is user online? He is. So I'll give 1 mention here. This user is still offline, so nothing here. And then this user is online, so I will mention here. So that's all our messages. What we'd return at the end would be this array of values from mentions. So we'd have 1 mention for user 0, 0 for user 1, and 2 for user 2. And this would be our answer. So what is the time complexity here? Well, first we actually have to sort our events, right? So this is going to be O of n log n. So we're limited by this, right? But we can look a little bit closer about what we're actually doing for the processing. So what we're doing is going through each event. So we're going to go through O of n events. Then for each one, we potentially have to go through everything in online, everything in mentions, and everything in queue. And remember, these can be up to size 100. So really for each n, we're going to go through potentially 300 for our online, for our mentions, and for our queue. But again, since this O of log n is bigger, we're just going to simplify it down to this and say that this is our bounding factor. We don't have to mention this, although it's good to know how this behavior will operate. So the first thing I do is just define this little helper function here. Probably not necessary, but I just found it kind of annoying to parse the ID strings we're given. So what we're doing here is just passing in whatever string that we're given. We're going to take whatever is at index 2 to the end and convert that to an integer. And that will just get rid of the ID string in the beginning and return the actual integer value. So in our main function, the first thing we're going to do is sort. And we have a custom sorting function here. So remember, what we want to do is we want to first sort by the timestamp. But if there are timestamps that are the same, we have to make sure that any offline or online events are happening before the messages. So what we're doing here is saying, I want to first sort by the timestamp, but then I also want to sort by the string value that is in message type. And I'm just doing this here because we're only going to have two values, offline or message, and just putting this here means that offline will come before message. So by doing this, it will just sort that in the order that we want. Then we're going to set up our three data structures that we need to keep track. So we're going to have our online, which will be a Boolean, our mentions will be integers, and our offline will be a dec. Then we're just going to go through our number of users and add them into our data structures. Then what we're going to do is we're going to go through all our events, convert our timestamp to an integer, and then here is where we're going to process online events. So while we have elements in our queue, and the timestamp that they come back online is less than or equal to our current timestamp, this means that these users are coming back online. So we can pop that value off, we can grab that user ID and set their online back to true. So then we're going to handle our different message types. So if we have an offline message, what we're going to do is we're going to append to our queue. So what we're going to do is say, I want to put a tuple where the timestamp I'm coming back online is my current time plus 60, and then the second element is going to be the ID that is coming back online. Then we're just going to set that user online to false. Otherwise, we have to handle the message event. So all is very simple. If our message is all, we just go through all dimensions and add 1. If the content is here, then what we need to do is go through all of our items in the online dictionary, and if they are online, if this value is true, then we can add a mention. The last case where we're just given a list of IDs that we have to parse. And what we do here is just going to split those on a white space, and then for each one, we're going to just mention them one time. Finally, at the end, we just return those values. So let's submit and make sure that it works. And it does. So hopefully this is helpful. This is not too hard of a problem, but really just getting through the description and all the different edge cases can be kind of tricky. So if this is helpful, please like and subscribe. It really helps. And thank you for watching.